Hello everyone, how are you today? Okay, before we start to the lesson, let me introduce myself first. My name is Gusti Kadek Reijugni, and today I will get you to learn about factor, especially the concept and application of factor. Before we begin, I want to ask you a simple question. Have you ever used Google Maps or seen a ship moving in the ocean? Okay, that's great. Actually, factors are very useful in daily life, especially for direction and movement. Today, we will learn how factors work and how to operate them mathematically. So, let's start our lesson. Okay, everyone, look at the screen. Today, we have three learning objectives. First, students are able to explain the definition of vector. Second, students are able to identify different types of vector. Third, students are able to apply vector operation. By the end of this lesson, I hope all of you can solve simple vector problem confidently. Are you ready to learn? Now, let's talk about the definition of a vector. A vector is a quantity that has both magnitude and direction. Magnitude means size or value, while direction means where the object moves. For example, if I say I walk 5 meters, that is not complete because there is no direction. But if I say I walk 5 meters to the east, that is a factor. Factor are, factor are usually represented by arrows. The length of the arrow shows the magnitude. The end and the arrow's head shows the direction. Can anyone give another example of factor in real life? Okay, yes, very good. Velocity, force, and this displacement are example of factors. Next, we will learn about the type of factors. A negative factor has the same magnitude but the opposite direction. For example, if one factor goes to the right, the negative factor goes to the left. A zero factor has zero magnitude and no specific direction. It is usually represented by a simple point. Equivalent factor have the same magnitude and the same direction. Even if their positions are different, let's look carefully at the illustration. Can you identify which vector have opposite direction? Okay, you can answer in the comment. Now, let's do short activity together. Please observe the vector labeled A until H. Your task is to find opposite factor and equivalent factor. I will give you 1 minute to discuss with your friend. Okay, well, everyone, let's discuss the answer together. Opposite factor are factors that have the same magnitude but opposite direction. Equivalent vector is a vector that have the same magnitude and the same direction. Very nice participant, everyone. Now we move to vector in coordinate system. A vector can be written using coordinates, for example, as a column vector or a row vector. Vectors also have components, usually the x component and y component. To find the magnitude of a vector, we use the Pythag- Pythag- Pythagor- Pythagoras theorem. This formula helps us calculate the length of the vector. We still remember the Pythagorean theorem. Next, we will learn vector addition. There are two ways to add vector, geometrically and by component. In geometrics method, we place the tail of the second vector at the head of the first vector. In component form, we simplify at the x component and y components. This operation is very useful in PC and engineering. Can anyone try to add two simple vectors? Now let's continue with vector subtracting. Subtracting a vector is similar to adding a negative vectors. We change the direction of the vector first, then add in, then add it. Geometrically, the vector direction changes to the opposite side. Please pay attention to the diagram. Do you think subtraction is harder than addition? Actually, the process is almost the same. Next is a scalar multiplication. A scalar is just a number. When a vector is multiplied by a scalar, the magnitude changes. If the scalar is greater than 1, the vector becomes longer. If the scalar is between 0 and 1, the vector becomes certain. For example, if a vector u becomes 2u, the magnitude doubles. Can you guess what happens if we multiply by -1? Yes, the directions becomes opposite. Now, let's solve an example problems together. We are asked to determine the result of several vector operations. When solving vector problems, always pay attention to the components and directions. Let's solve it by step. First, identify the vector. Second, apply the operation. Third, simplify the result. If anyone has a if anyone has a different answer, don't be afraid to share it. Mathematics is not only about the final answer, but also about the process. Now, let's see a real-life application of vector. A shift move is a sorry. A shift mode is 60 kilometer per hour, while the ocean currents moves north at 30 kilometer per hour. We need to determine the total velocity of the sea. This is a perfect example of vector addition in daily life. Can you imagine the direction of the ship? Yes, the ship moves diagonal because of the combination of two vectors. Let's solve the problem together. We combine the vector using vector operation. To find the magnitude, we use the Pythagorean theorem. The result is approximately 67 kilometers per hour. So the ship does not only move east or north, but diagonally with a greater resultant velocity. Do you understand how vector applicate in real situation now? Okay, I hope you can understand. All right, everyone, we have reach the end of today's lesson. Today we learned about the definition of vector, type of vectors, vector operation, real life application of vector. I hope this lesson help you understand vector better. Thank you for attention and participation. Before we finish, does anyone have question? If you have question, you can written in the comment. If there no question, thank you everyone and see you in the next lesson. Bye bye.